I've written a sort of calculator program that takes user input and then performs an operation that they choose. And so I'll run it to show you what I mean. Okay, so enter some numbers and then enter 0 when I'm done. Well, I wonder what numbers I'm going to choose. We'll at least put them in an unconventional order. And then it says enter some numbers, enter 0 when you're done. Okay, so I'll enter 0. Now, pick an operation. Okay, so I'll pick sum, because I already know what the sum of those numbers is. It's 33. Oh, that's nice. Okay, so how does this program work? Well, I've got functions that do the various operations. There's the sum operation. There's the multiply operation. And although in a different setting we might discuss whether these can be abstracted a little bit, whether we can decouple these, we won't worry about that for today. And then I've got finding the maximum element. I've got finding the minimum element, and I've got a function to find the mean. So if the user asks for the mean, that's pretty easy. I just sum the vector up and divide by its size. And I throw exceptions in various cases because obviously I can't compute the mean of a vector with no elements. I can't compute the minimum element if the vector has no elements, and so on. But the logic I want to talk about is actually in main. So I ask the user to enter some numbers, and I read them into a vector. All of that's pretty much by the books. And then I want to print out the list of operations. Okay, there it is. I've had to enter the list of operations in manually. And then I read an operation from them. So if they don't enter an operation, I go down here and say, you know, what's the deal? But if they do read an operation, if they are able to enter some string of text, then I have to decide which operation to run. And so I use this stack of if statements. Because up until this point, obviously what I do, like with the result, depending on each string that could have been entered, requires different code. So I have to write different code for each case. Now there is a way I could simplify this a bit. For example, I wouldn't need to duplicate the print statement. If I added an extra Boolean variable or something, or another layer of if statements, I could avoid duplicating this if statement, or this result, this print statement here. But ultimately I have to call a different function inside of each case, which means if I'm doing it the old-fashioned way, I end up with this big stack of if statements. Now think about what would happen, and then the program ends. Think about what would happen if you wanted to add, I don't know, 100 more operations. Do you really want a stack of 100 if statements? Not only because that's just a mess, it's a lot of stuff to do, but because it's also very error prone. So I decide to add in one more operation to compute, I don't know, the median. So I'm like, okay, so I do, I don't know, compute the median of the vector. What if I forget to update this string? There are two things I have to change at each step, and I could forget to update one of them. What if I forgot to go up here and add median to my list of operations? That's pretty tedious. If there are going to be 100 operations, I don't want to have to worry about that. There are a lot of places I could make a mistake. And actually, even beyond that, so suppose I wasn't worried about making that kind of a mistake. Suppose I could trust myself, or I was willing to go through and scrub through all that debugging. When I have a huge stack of if statements, doesn't that take the compiler a long time? So I've asked for an operation. I asked for the operation multiply. And the only way I could find, up until this point in the course, until a minute from now when I show my other version, the only way I could find to decide which operation to run is a big stack of if statements. So the compiler has to generate code that asks, was it the string max? No. Was it the string mean? No. Was it the string min? No. It might have to ask 100 questions before it gets to the answer. But really what I'm doing is searching a collection. I've got a bunch of operations, a collection of operations. I want to quickly find the one called multiply. Doesn't the language have facilities for that? Doesn't the language offer us some easy way of having a collection of objects and searching them quickly? Well, yeah, that's a set. And if I want the case where I have a collection of objects that have some associated data, so the string min, for example, is associated with the function min element, well, how do I quickly search a collection that by one of the parts of the pair? So I've got a pair of a string and a piece of data. How do I quickly search it by that string? Oh, wait, that's a map. Wouldn't it be great if I could use a map instead of having to make a big stack of if statements that are error prone and might well be slow? Well, fortunately for us, because of what we've just learned in the last few videos, we can do that. So over here, I have a variant of exactly the same program, all the same functions, sum vector, multiply vector, max element. And here we'll take a moment to appreciate that all of them have the same signature pretty much. It takes a vector of double by constant reference, returns a double, that's the sum. Returns a double, that's the product. Returns a double, that's the maximum element, and so on. But here what I've done is I've leveraged the fact that I am allowed to treat a function as data. So I've made up a map. The map carries strings, which are my keys, the name of the function the user uses, like sum or multiply. It carries those to function objects. And I then insert all of my functions into this map. And that yields all sorts of interesting benefits. So for one thing, I don't need a stack of if statements. But even better, if I want to generate for the user a list of all the operations, I guess we should compile and run this version before I show it off any further. So we'll do that. if I want to show the user my list of operations, the map actually provides them to me. So let's enter some numbers again. I guess I'll enter the same 3 numbers to be scientific, and then enter 0. We'll ask for the sum, and sure enough, it's 33. So when I ask the user, enter one of the following operations, now I just print out the operations from the map. If I want to add an operation, I add it in one place. I never have to worry about forgetting to update my list of operations here, and even better, if I want to run the operation, so I ask the user to enter an operation. If I want to run that operation, all I have to do is search the map. First I say, okay, if the operation you entered isn't there, then obviously we need to print an error. Otherwise, the operation is present. Go grab it from the map, go grab the associated function from the map, call the function, print it out. I've managed to condense down what would otherwise be a growing stack of if statements into one, I think, really concise piece of code. I am letting the map do all of the work for me. So now I can quickly search for the thing I want. I don't have to worry about that stack of if statements being a linear search. The map is very good at searching and I trust it. So I have the map do the search. It finds me the operation I was looking for. I then just call the function because I was able to retrieve the function as a piece of data, and then I print the result. I think this is a very concrete reason, outside of just the abstract idea of decoupling things. This is a very concrete reason that treating functions as data can pay dividends. Because now I can add as many operations as I want. I don't have to worry about the code expanding to a point where I can no longer keep it under control.